Okay, we're going to do some Unit 1 review problems together. So let's read this carefully. This question is number 5 from your Unit 1 review. Jennifer took the ACT and scored a 29. Okay, the ACT and scored a 29. She took the SAT and scored a 1350. ACTs have a mean of 21 and a standard deviation of 4.7. SATs had a mean of 1026 and a standard deviation of 209. On which test did she perform relatively better? Okay, we know that to answer this question, we must compute two z-scores and compare them. So what we're going to do is we're going to use ACT information on one side and SAT information on the other, and then I'll rewrite my z-score formula in bright red so everybody remembers. Z was equal to, we had it in two ways, x minus x bar all over s, or we could write it with the Greek letters. Z was x minus mu, that's the mean, all over the standard deviation. Either way, I'm still using the same formula. Take the data value, subtract the mean, and divide by the standard deviation. So for the SAT, we need an x bar, and an s. And for the SAT, we need the same, x bar, and s. So the ACT, we know the mean was 21 and the standard deviation was 4.7, meaning her actual score is our x value. For the SAT, we know the mean was 1026, the standard deviation was 209, and her actual value is left as her score, 1350. So now we do our z-score computations. We take the actual data value, subtract the mean, and divide by the standard deviation. We'll do it again on the SAT side. Take the actual data value, subtract the mean, and divide by the standard deviation. And if we do this for both values, for the ACT, I get 1.70, and for the SAT, I get 1.55. And remember, we are still not done. We're asked on which did she do relatively better. So we compare the two scores. Look at the sizes. She did relatively better on the ACT because it's more standard deviations above the mean. Okay, 1.7 is further away above the mean than 1.55. All right, we're going to move on to question number 6 together from the review. It says the cost for standard vet services at a local hospital follow a bell-shaped curve with a mean of 90 and a standard deviation of 30. Then it says to draw the bell-shaped curve. So what we want to do is draw an axis, and hopefully a better bell shape than I just drew, but draw a bell shape on top of it, and then draw your 7 tick marks, 1 in the middle and 3 on either side. The middle represents the mean, so I'm going to put in $90 for the mean. Every time I move to the right, I'm going to add the standard deviation. So that would be 120, 150, 180. Okay, and on the left-hand side, I will subtract the standard deviation, which is $30. So that would give me 60, 30, and 0. Now we are asked, between which intervals will you expect the central 68, 95, and 99.7% of students to fall? That information requires us to understand that 68 is plus and minus 1 standard deviation away from the mean, 95 is plus and minus 2 away, and 99.7 was plus and minus 3 standard deviations away. So looking at our chart, the 68% lies between 60 and $120. So I should put dollar signs. Okay? That's 1 standard deviation to the left, 1 standard deviation to the right. All right, let's change colors. 95% lies between $30 and $150. So that's here and here. And finally, let's jump all the way out. 99.7% lies between, we're going to go all the way to the edges, $0 and $180. So we can jump from the center out 1, 2, and then 3 standard deviations each to answer that question. Okay. Then it says compute the z-score for a vet bill of 125. All right, well, we already know that formula from question number 5, so let's rewrite it. X minus mu all over sigma, right? So I'm going to take z equals, the number they give me is x, so 125 minus the mean, which was 90, all divided by the standard deviation of 30. So if you put that in your calculator, you should get that the z-score is 1.6666, so I'm going to round it to 1.67. So that would be 1.67 standard deviations above the mean. Try it again in part D. Compute the z-score for a vet bill of 75. So again, they give me x, and we want to do 75 minus the mean of 90, all divided by the standard deviation. And in this case, we end up with negative 0.5 as our z-score. What this tells me is that we are half a standard deviation below the mean. All right, this final question says, what cost does a customer with a z-score of 1.75 have? So this is actually a little bit different. They give me my z-score and ask me to find x. We had an equation. It looked like this. X equals z times s plus x bar, or it looked like x equals z times mu plus sigma, depending on if you use the Greek or the Latin letters to represent that. So our formula would look like x equals, we take our z-score of 1.75, multiply by the standard deviation of 30, and then add 90. And if you do that, you end up with a cost of $142.50. Okay, we're going to go ahead. We're actually going to go to sampling methods. So we're going to go to question 11 first, and then we're going to backtrack to the linear regression. So we're going to go back to chapter 1. Okay? So I'm on question 11. This is sampling methods. Sampling used. What were our choices that we could choose from? We had census, simple random sample, a systematic sample, stratified, cluster, voluntary, and convenience. Okay, those are our types of sampling methods. It says a man inherits a house full of possessions from a relative. The house contains many bowls, paintings, and old books. He wants to get a sense of what the possessions might be worth, so he picks a few bowls, a few paintings, and a few books to bring with him. Okay, so first it says there are 3 groups: bowls, paintings, and books. So first there are 3 groups. Then he picks some from each group, chooses some from each group. When we have our sampling method where we actually go to every group and we choose a little from every group, that is stratified sampling. All right, let's go to the next one. Your coworker is interested in changing primary care physicians. She asks you and your fellow coworkers for their opinions. She did not plan. She did not use randomization. She simply asked those closest. Asks those closest. This was easy and lazy. So this is a convenience sample. One more time. a list of students' student IDs are randomly generated, and those with matching ID numbers receive an email survey. Students who do not respond to the survey are sent reminder emails. Okay, so this stops non-response, right? This allows students to have more than one opportunity to respond, which means this is not voluntary. Voluntary means they get the survey once and we just wait. These people are randomly selected and repeatedly asked to answer. This here, being randomly generated, implies that this is a simple random sample. The numbers were generated with technology, right? That's how we would use a random number generator. All right, we're going to go one more time. All Math 138 students, all the students, are required to take the final exam. The results are investigated to explore areas which may need further attention in subsequent semesters. Okay, if everyone does this and no one is left out, this is when we achieve a census. The entire population was surveyed with that exam. There are more examples of sampling methods in the beginning of our packet. There are even more examples of sampling methods and bias in the extra Unit 1 review that is posted on Canvas on our Unit 1 review page under modules. Keep using examples if you struggle with this. One more problem, y'all. Okay, we're on to linear regression. So I've already put all the data in my calculator, so I'm going to run through the steps of finding these values, but I put years since 1970 in list 1 and the GPA in list 2. And first it says compute the correlation coefficient. So right above that, I'm going to say that that's the letter R. And to do that, we have to do stat, arrow to the right to calc, and select option number 4, which is the LinReg option. You can also select option number 8 as per Alex. The last value on the screen is our R value that we can report, and I got 0.988. So this, first of all, is positive. So it's positive, strong, because it's close to 1, and therefore linear. And that is because this is very close to positive 1. Remember that closeness to positive 1 means something is strong, and when something is strong, we also consider it linear. So without leaving the page on your calculator, we also want to write the linear model. And when someone says the linear model, they mean to write y hat. So right there, we have our slope and our y-intercept on the same calculator screen. So it says 5 decimal places. That's ridiculous, but we'll do it. 0.01112x plus 3.01371 is my linear equation. Now we're asked to interpret the slope. This is sounding very familiar. So the slope is always the number touching x. So our slope is 0.01112. And it says, for each additional, and then we always put in our x variable. Okay? And then y variable, in this case, increases because my slope is positive by, and then I'm going to have a blank again. I'm going to go ahead and fill in my blanks. For each additional x, so this is year since 1970, the y, so the GPA, increases by, and then we put the slope, 0.01112. All right, one more time, read it out to yourself. For each additional year since 1990, the GPA increases by 0.01112. Sounds reasonable, given our line is increasing. Then it says, use the model to predict the average GPA for the year 2015, or 45 years after 1970. So right away, they just told us x is equal to 45. And when it says predict, that means use y hat. Predict and estimate mean the same thing. So this says find y hat when x is 45. Okay, we're going to plug in 45 for x. And when you do that, if you use every one of those decimal places, I rounded the GPA to 2 decimal places, I got 3.51. So right now, I know what I predicted to be true in 2015. Now, in part E, it says, suppose the actual GPA in 2015 is 3.48. Compute and interpret the residual. Okay, so real quick, before we even start talking about the first sentence, I'm going to write that a residual is equal to the actual minus the estimate. Or, if we prefer, that looks like y minus y hat. Okay? So, what are we given? It says the actual GPA in 2015 is 3.48. So right now, they're literally telling us x comma y is 15 years. Oh, sorry. That was from class. My bad. 45 years and 3.48. So that is y. All right, go into your equation for the residual. We take the actual GPA from 2015, I'm so sorry, which is 3.48, and subtract the guess, our estimate from 2015, which was 3.51. And right here, I could compare the two numbers. Is 3.51 over or under 3.48? It is, in fact, larger. So we will have an overestimate here. And when we do this math, we find out that our residual is negative, which means it's an overestimate, but we only overestimated the GPA by 0.03. So we were very, very close. Okay, happy studying. Let me know what kinds of questions you have. I am here for you, and you can do this.